Welcome to the DIY Honda Garage channel. Welcome to the diagnostic presentation for DTC P0615, which indicates a malfunction in the Starter Relay STRLD circuit for the Honda HR-V models from 2016 to 2022. The starter relay plays an essential role in the vehicle's starting system by controlling the flow of electricity to the starter motor, thereby enabling the engine to start. The issue can often manifest due to several factors, including poor connections, faulty components, or open circuits. To ensure an accurate diagnosis and effective repair, we will follow a structured troubleshooting approach consisting of specific steps. This guide aims to help you understand not only the symptoms and causes associated with the DTC, but also to guide you through the troubleshooting and verification processes effectively. DTC P0615 signifies a malfunction in the Starter Relay STRLD circuit. The starter relay directly influences the startup process by connecting the battery's power to the starter motor. The relay is generally located in the underhood fuse relay box, making it accessible for inspection or replacement. Additionally, the powertrain control module, PCM, is integral, as it manages the relay's activation based on the ignition switch position and other engine conditions. This communication between the PCM and the starter relay is critical for proper engine operation. Furthermore, fuses must also be checked, as they provide protection to the electrical components, and any blown fuses could lead to a similar error code or prevent the engine from starting altogether. The potential causes of DTC P0615 are primarily linked to electrical issues. Poor connections can disrupt the necessary flow of electricity needed for the starter relay to engage properly, leading to a malfunction. Loose terminals can also cause intermittent connectivity, which contributes to reliability issues during starting. Moreover, faulty relays or wiring can severely impair the electrical system. If the starter relay itself is defective, it will not function as intended. Blown fuses such as the B25 and C26, which protect the starter relay circuit, can further complicate the situation, requiring inspection during the troubleshooting process. By considering these factors, technicians can pinpoint the area of failure more efficiently. Symptoms associated with DTC P0615 typically involve starting issues. The most notable symptom is that the engine won't start at all, indicating a failure in the starting system. Drivers may notice that upon turning the ignition, there is either no response or a clicking sound emitted from the starter relay, which shows it might be attempting to engage unsuccessfully. The onboard diagnostic system will indicate the presence of DTC P0615, which alerts the driver or technician to investigate further. As the starting system relies heavily on the relay's function, any irregularities detected here will manifest prominently, underscoring the importance of troubleshooting these symptoms effectively. The first step in troubleshooting DTC P0615 involves verifying the problem. Begin by turning the vehicle ignition to the on position without starting the engine. Following this, clear the DTC using the Honda Diagnostic System, HDS, which resets the vehicle's fault memory. This step is critical because it ensures that any transient faults are cleared before proceeding. After clearing the DTC, attempt to start the engine. This will help in determining whether the issue is intermittent or present. Then, check for any pending or confirmed DTCs, again using the HDS to see if P0615 reappears, which will help in confirming that there is a persistent issue that needs addressing. In this step, you will need to check for any pending or confirmed DTCs once again using the HDS. Specifically, look for codes P16F3 and P16F4, which indicate low voltage in the starter cut relay 1 and 2 control circuits. If both of these codes appear alongside P0615, it suggests a shared electrical issue that must be addressed. If those codes are confirmed, proceed to troubleshoot P16F3 and P16F4 as indicated in the respective procedures. If neither code appears, continue on to the next step in the process. Being thorough in checking these codes will ensure that all potential problems related to the starter circuit are identified. Step 3 requires you to try starting the engine. Observe whether the engine starts or not, which provides important diagnostic information. If the engine successfully starts, this confirms that the problem may not lie within the starter or its immediate circuit, and you should further investigate related components. Conversely, if the engine fails to start, proceed to step 6 for further investigation into the issue. This step is crucial, as it provides immediate feedback on the system's current operational condition and helps narrow down the potential failure areas accordingly. For step 4, the vehicle should be turned off to ensure safety while conducting electrical inspections. Proceed to check fuse number B25, which is a 7.5 amp fuse located in the underhood fuse/relay box. This particular fuse is integral to the starter relay circuit, so determining its integrity is critical. If the fuse is intact, you will proceed to the next step. However, if the fuse is blown, it will need to be replaced, and you should also check for any wiring issues that might have caused the short circuit on the B25 fuse circuit. This step is vital in ensuring the electrical pathways are clear and functioning properly to support the starter relay. In step 5, again turn the vehicle to the off-lock mode to conduct electrical checks safely. Begin by removing starter cut relay 1 from the underhood fuse relay box. This step is crucial to isolate the components. After removing the relay, you would then jump the SCS line using the HDS, a diagnostic tool that allows you to conduct specific system checks. Disconnect the PCM connector A51P for further integrity checks. You will then need to check for continuity between designated test points to ensure that the start diag STRLY 1 to 2 line is intact. If continuity exists, then the wiring is functional, and you can proceed to update the PCM if required. Otherwise, you will need to repair any open circuits found in this line to restore functionality. Step 6 begins once more with the vehicle in the off-lock position to ensure safety. Inspect fuse number C26, which is another 7.5 amp-hour fuse located in the under-dash fuse relay box. This fuse is similarly crucial as it impacts the starter cut relay operation. Should the fuse be functional, you may need to repair any open circuit in the IG1 ST cut RLY wire between this fuse and starter cut relay 1. If the fuse is blown, it is vital to check for potential shorts in the IG1 ST cut RLY wire. Addressing any shorts and replacing the C26 fuse is crucial to restoring the normal operation of the starter circuit. Ensuring both fuses are intact and functional will significantly improve the odds of resolving the DTC P0615 issue. Once all repairs have been made, it is vital to conduct a final verification to confirm the effectiveness of the work completed. Begin by attempting to start the engine, which should ideally engage smoothly without any abnormal sounds or behaviors. After starting, conduct a scan using the HDS to check whether DTC P0615 has reappeared. If the code remains absent, it is a strong indication that repairs were successful and the issue has been resolved. This step is essential not just for technician satisfaction, but also to instill confidence in the vehicle's reliability for the driver. Ensure that any previous DTCs have also been cleared and that the vehicle exhibits normal starting behavior in real-world conditions. Preventive maintenance plays a key role in the longevity of your vehicle's components and overall performance. Regular inspections of fuses, especially those related to the starter relay, can help identify potential problems before they lead to more significant issues. Similarly, periodic checks of all electrical connections ensure that terminals remain tight and free from corrosion, maintaining the integrity of the starter circuit. Additionally, ensuring the PCM is updated to the latest software version can significantly improve vehicle responsiveness and reliability. These practices not only assist in avoiding DTC P0615, but enhance the vehicle's overall performance and reduce the risk of unexpected failures. In conclusion, DTC P0615 indicates a fault in the Starter Relay STRLD circuit, which can lead to significant starting issues in the Honda HR-V. To effectively diagnose and address this DTC, it's essential to follow the structured troubleshooting steps we covered. Checking the integrity of fuses, connections, and related components is paramount to identifying the underlying issues. The process must be systematic, ensuring no step is overlooked. By adhering to preventive maintenance practices, you can prolong the lifespan of the starter circuit's components and avoid potential concerns in the future. Your commitment to proper diagnostics and repairs will ensure a more reliable vehicle for your driving experience. Please like and subscribe to the channel. See you next time.